Hello everyone. So today I am going to calculate the eigen vector corresponding to a particular eigenvalue for a given matrix C. Okay. So again, this particular problem is related to PCA. Okay. And this particular numerical I have picked up from the quizzes of NPTEL course Deep Learning. Okay. So here what we are given these three data points x1, x2, x3, the which are given in the form of a vector, right? Now I have to calculate the eigen vector corresponding to the maximum eigenvalue of the covariance matrix C. Okay, so this C is nothing but a covariance matrix. Now to reach this eigen vector I have to follow some steps. Okay, for example, here these data points that are given x1, x2 and x3, I have to first find the mean of these data points. Okay, then after calculating the mean I will be calculating the covariance matrix. And to calculate a covariance matrix I have this formula C equal to 1 by n, then summation I equal to 1 to n x minus x bar. This x bar is nothing but the mean that just now we have calculated, and multiplied by x minus x bar transpose. Okay, so this is the formula to find out the covariance matrix. And what is the third step? Once I find out the covariance matrix, I have to find out what? I have to find out eigenvalue. Again, to find out the eigenvalue I have an equation. The equation is this C matrix, this covariance matrix C, determinant of C minus this lambda. This lambda is nothing but the eigenvalue which is unknown for me. This multiplied by the identity matrix, determinant of this should be 0. Okay, so from this particular equation I get eigenvalue. Okay, it depends on the root of the equation. If the root is 2, then I will get 2 eigenvalues. Now from the previous problem that we have discussed, this problem only in the previous video I got eigenvalue as 0.33 and 0.11. Okay, and what is the current question? Now I have to calculate the eigen vector corresponding to the maximum eigenvalue. So out of these two values, 0.33, that is the maximum value. Now to calculate the eigen vector, corresponding to this particular eigenvalue 0.33, again I have a equation here. What is the equation? C, that is the covariance matrix that we have calculated in a previous video, multiply minus lambda. Lambda is nothing but this particular eigenvalue multiplied by this identity matrix, then again multiplied by this x. X is nothing but this is what I need to find out, that is my eigen vector. Okay, equal to 0. So again this 0 is nothing but a 0 matrix or null matrix. We'll see how I'll be calculating. So today's video is on this formula, the step number 5. I have to find out the eigen vector. Okay, now let us proceed on this. Let me go to the next slide here. So as I have told here, the maximum eigenvalue that we have calculated for the given data points, that maximum eigenvalue is 0.33. Okay, and the and the covariance matrix that we have calculated again in a previous video, the covariance matrix for the given data points is 0.22, then minus 0.11, minus 0.11, then 0.22. Okay, this is the covariance matrix. Now to find out the eigen vector, the formula that just now I have given, C minus lambda I multiplied by x equal to 0, right? So I will substitute my known values here. So what is the C matrix? That is nothing but 0.22 minus 0.11 minus 0.11, 0.22, yes, this minus lambda value, that is nothing but 0.33, multiplied by the identity matrix here. So the identity matrix will be nothing but 1 0 0 1. I hope it is clear why I have taken a 2 by 2 identity matrix, because the matrix from which I have to subtract this value, it is a 2 by 2 matrix. Okay, so this then multiplied by here the eigen vector matrix. Okay, so this eigen, it's a vector. Okay, so the eigen vector will be represented by the vector x1 with the elements x1 and x2. Okay, and finally as I told, the zero matrix or the null matrix, that will be again 0 0. Okay, so here this entire first part, okay, what will be the final value here? This value is 0.22 minus 0.33, right? These two will be multiplied and then we'll subtract from this value, then minus 0.11, then minus 0.11, and similarly here as well 0.22 minus 0.33. Yes, so multiplied by the eigen vector equal to the zero matrix. So here this is a 2 by 2 matrix and this one is 2 by 1 matrix. So this particular matrix multiplication will yield me a 2 by 1 matrix, right? That's why the size of this zero matrix is 2 by 1. Okay, so we'll go to the next slide to do the final calculation here. So once we do the multiplication, we get this particular 0.11 x1 with the minus 0.11 x2. Okay, and the second element will be minus 0.11 x1 minus 0.11 x2. Okay, as I told, this is nothing but a 2 by 1 matrix, and then I have my eigen vector here equal to 0 0. Okay, again this one is again 2 by 1. Okay, so as you can see, both the equation here are same only. It is minus 0.11 x1 minus 0.11 x2 equal to 0. Both the equation are same here, so I am not repeating it. So finally I have this particular equation from the given formula. Okay, so here if I further simplify this particular equation, it will be x1 plus x2 equal to 0, right? So which is nothing but you can also represent as x1 equal to minus x2. So from this particular equation, simplified equation, we can understand that whatever be the value of x2, okay, the x1 will have a value which will be negative of that x2 value. So finally I can have eigen vector as eigen vector was represented by x1 then x2, right? So it will be x1 is what, minus of x2, and x2 is just x2. So if I take x2 as 1, the the x1 value is nothing but minus 1, right? Similarly, this is the answer for the eigenvector. Similarly, there can be another solution to it as well. From this equation only I can have what, x2 equal to minus x1. So corresponding to these, I will be having the eigenvector equal to x1 x2. It's nothing but here it will be x1 only, and what is the value of x1? It is minus x1, right? So if I take the value of x1 as 1, the x2 value will be minus 1. So this is again another correct solution. So either of both at the same time are not correct, either this one or the other one. Okay, so that will be my eigen vector. Now if I go back to the possible options that is given, okay, we have to also see what are the options that is given. So the option is 0.171, 0.71, then next one is minus 0.71, 0.71, then one is given minus 1, 1, right, and 1, 1. So out of all these 4 options, the most probable one is minus 1 and 1. This is the correct option, right? So thank you.